First welfare theorem. So what exactly does first welfare theorem talks about? It says this that whether all market equilibria are the Pareto efficient or not. And it says that yes, all market equilibria is Pareto efficient. So let me just start writing this. So whether competitive market can really exhaust all the gains from trade. And where do you think the gains from trade are going to be exhausted? At the Pareto efficient outcome. All the gains from trade, right? And the other question is that once you have established that demand is equal to supply in all the markets, that's what the market equilibrium is. So if demand is equal to supply in all the markets, will there be any more trades which can happen? So once demand is equal to supply in every market, will there be any more trades? Will there be any more trades, right? Basically, it is a polite way of asking whether the market equilibria is Pareto efficient or not. So that's what we will be proving also, whether market equilibria is Pareto efficient or not. That's what we need to say. Suppose it is not. Suppose you have the market equilibrium, but it is not Pareto efficient. Supposedly. Suppose not. Means you have the market equilibrium, but that is not Pareto efficient. So it means that there is some other allocation which is feasible also and which you also prefer on the market equilibrium, right? So there is a market equilibrium, but you are saying that that is not Pareto efficient. So if it is not Pareto efficient, it means that there is some Pareto superior allocation which is going to exist. So that allocation is going to be preferred to this allocation. So although you have the market equilibrium, but that is not Pareto efficient. So please write to say that market equilibrium is not Pareto efficient means that there is some other feasible allocation. And what can that feasible allocation is? There are two individuals, A and B, there are two goods, 1 and 2. For example, you can say earlier, this is what I was consuming. I was individual A, and this is what you were consuming. You were individual B of good 1 and 2. But now we say that there is some other allocation Y, means Y1A y2a, right? And y1b, y2b, y2b, such that such that your y1a plus y2a, that is the amount of such that y1a plus y1b, that is the amount of good one which is demanded by A and demanded by B, should be equal to the total supply of good one. So total supply of good one is, I have W1A, you have W2A. Similarly, the total demand for good 2, what am I writing? I'm so sorry. Total demand for good 2 by individual A plus, and here also it is B. I'm so sorry. Total demand for good 2 by B should be equal to the total supply of good 2 by A plus total supply of good 2 by B. Right? So this is the total demand, this is the total supply for good A. This guy, this should be 1. I'm so sorry. Right? So this would mean what? That the allocations are feasible. Allocation is feasible. Right? Okay. So first thing is this, that you were saying that this is not Pareto efficient. This allocation is not Pareto efficient. It would mean that there is some other allocation uh, which is Pareto efficient. It means that this allocation, this new allocation, is Pareto superior to this one, and this is feasible also. So feasible we have written. Let me write for uh, that this is going to be preferred by each agent. So the allocation, your y1a, write this with black only, y1a and y2a, right, is going to be preferred by A over the original bundle which A has of good 1 and good 2, right? Similarly, y1b, y2b, individual B is also going to prefer the y allocation over the x allocation. Individual B is also going to prefer y allocation over x allocation. So y allocation is preferred by each agent to X allocation. So it is preferred by each agent to X allocation. Now you understand one thing though, where you have the market equilibrium, it means that each agent is purchasing the best bundle he or she can afford. So if she was purchasing, if I am purchasing good A, if I am purchasing allocation X, which is X1A, X2A, and you are purchasing the allocation X, which is X1B, X2B, it means that you are purchasing the best bundle which you can afford, right? If now we have started preferring Y bundle over the X bundle, then it would also imply that Y bundle is going to cost us more, right, than what we can afford. That's what it is, because in that case, uh, the market equilibrium would mean that I am choosing the best bundle which I can afford. Now, the better bundle than what I can afford is, of course, there could be many other better bundles, but they are not affordable. They are beyond my reach. That's what it is. Uh, so please write this. But by hypothesis, we have a market equilibrium where each agent is purchasing the best bundle he or she can afford, right? So if you are saying that Y bundle is better than the X bundle, then what you are necessarily saying is that fine, Y bundle could have been better than X bundle, but of course you cannot afford it. That is going to cost you more than what you can afford, right? So if Y1A, Y2A is better than the bundle A can afford, right? Then it must also cost more than what A can afford, right? Than what A can afford. Means what? Right. So I'm individual A and you guys are individual B. So I'm consuming what? Y1A and Y2A. At what price I'm consuming? P1, P2. What is an expenditure? P1 Y1A plus P2 Y2A. This has to be more than what I can afford. My endowments are Y1A, Y2, sorry, W1A, W2A. What is the value of my endowment then? P1 W1A plus P2 W2A. That's what it is, right? Similarly for B, right? P1 Y1B plus P2 Y2B greater than P1 W1B plus P2 W2B, right? It should be greater than. So when you will add both of them, adding them, what will happen? P1 Y1A plus Y1B plus P2 Y2A plus Y2B greater than P1 W1A plus P2, sorry, P1 W1A plus W1B plus P2 W2A plus W2B. Right, beta? Now you tell me one thing. You've just written this, that y1a plus y1b is equal to w1a plus w1b, and y2a plus y2b is equal to w2a plus w2b. That means these allocations are feasible. So in place of y1a plus y1b, I can write this guy, w1a plus w1b. That's what I can do. So p1 w1a plus w2a plus p2 w1b plus w2b. Right, beta? Uh, this will also be greater than p1 w1a plus w1b plus p2 w2a plus w2b. So just think about it. I hope you understood this. That is, I can write this y1a plus y1b equals to w1a plus w1b. That's what I have written out here. Right? w1a plus w1b. What am I writing? I'm so sorry. I mean, these notations are so confusing. W1A plus W1B. I'm so sorry. Hmm. Huh? That's what you can write. This is right. Ah, this is right. How is this possible? This guy is not possible now. And similarly for y2a plus y2b. So can this be possible? No. This is this same thing. So you're getting 2 here, you're getting 2 here. So 2 cannot be greater than 2, right? This is a contradiction. Which is a contradiction, right? So you have derived this contradiction by assuming that the market equilibria is not Pareto efficient, and you're getting this contradiction. So it means that your initial assumption is false. Hence, market equilibria is Pareto efficient, right? So hence, our initial assumption is false, right? So what follows is that all market equilibria are indeed Pareto efficient. It follows that all market equilibria are Pareto efficient, right? So what is first welfare theorem guaranteeing? It is guaranteeing that that a competitive market will exhaust all gains from trade. Yes. And if there is an equilibrium which is achieved by the set of the competitive markets, that will indeed be a Pareto efficient outcome, right? But the first welfare theorem doesn't say anything about the distribution, right? Or whether the distribution of the economic benefits, whether there should be just or not. It doesn't say anything about this, right? So although this is completely silent on, it doesn't say anything about, does not say anything about the distribution of economic benefits. The distribution of economic benefits. You may have a market equilibrium, but maybe that market equilibrium is not just. So maybe you have a market equilibrium, we have a market equilibrium in which I have everything and you don't have anything. So I'm starting with that position in which I have everything and you don't have anything. That can be an equilibria. And after trade, I will also, I mean, since I have everything, I have everything. I will not trade anything with you, right? So that would also, if before trade I'm owning anything, I'm owing everything. After trade also, I'll owe everything because I'm starting off with that position in which I have everything. So that market equilibria is there, but that market equilibria is not just, right? So but first welfare theorem, it doesn't say anything about the distribution of economic benefits, right? So it doesn't say that that equilibria has to be a just equilibria or not. No. So what is it that you have learned in this? You've learned how to prove that market equilibria, which you're getting from the competitive outcome, that is indeed a Pareto efficient outcome, right? And so all market equilibria are Pareto efficient. Right? They have to be Pareto efficient. And first welfare theorem doesn't say anything about whether the distribution is just or not. Right? Okay. Thank you, Beta.